This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
As you all know, Master Brewers is a nonprofit organization. You probably also realize that it's expensive to produce shows like the Master Brewers Podcast every week. If you're a vendor, please consider sponsoring the Master Brewers Podcast. It'll cost you less than you probably spent to sponsor that last district meeting, and your message will reach the thousands of brewers who tune in each week. Click contact from masterbrewerspodcast.com to learn more.
Once you do get some extraction, how to get the hops efficiently out of the beer without taking a lot of beer with it. You get higher levels of the aromas after just several hours, 3, 4, 5 hours, than you do after 3 or 4 days of a conventional dry hopping process where there is no mixing.
This week on the show, dry hopping. We've got to do it, but how do we optimize extraction and minimize loss, especially in large vessels? This week's guest thinks she's got a solution, and she's looking for brewers who want to give it a try.
Hello, my name is Alyce Hartvigsen. I'm the Isomix and Fermentation Manager at Alfa Laval in Denmark.
Alyce, let's hear about some of the challenges associated with dry hopping that the Isomix external drive was designed to address.
Well, dry hopping has been growing in popularity in larger and larger breweries. Originally, mostly it was done by smaller craft breweries, and their process has been normally to put the hops into a fermentation or maturation tank and let them sit there for some days to extract the good aromas and flavors that make dry hop beer so nice, and then to tap the beer off and either sludge the hops out the bottom or tap the beer off at a higher level so that the hops remain in the tank. Now, as the interest in dry hopping grows and larger breweries want to do it, they're trying to do the dry hop process in a larger scale, and there's some very special challenges that they've seen. Basically, for one, how to get the hop aromas extracted efficiently into large volumes of beer. If you put the hops into the tank, they will, for the most part, settle to the bottom. And if it's a very large tank, they'll sit and you don't get a very good extraction. Try to imagine making tea by putting a tea bag into a very large cup and letting it sit there on the top. It would float. But it wouldn't be a very efficient way to make tea if the tea bag just kind of sat in the top of the cup in a very large volume of water without any motion at all. That's one challenge. Another challenge is once you do get some extraction, how to get the hops efficiently out of the beer without taking a lot of beer with it. I think typical losses, beer losses for this kind of dry hopping can be up to 20 to 30% or higher. And when you're using expensive hops to make special craft beers, 20 to 30% product loss, that gets pretty expensive. Other challenges are that some breweries try to remove the hops using centrifuge. And basically, the difficulty there is if you're transferring the beer out of the tank, the hops, as a rule, most of them tend to settle to the bottom. You can sludge those off, and then you're transferring the beer through to the centrifuge. Now, one very curious thing about the way the hops settle in the tank, which many have seen and I've tested actually on a bench scale, is that although most of the hops settle to the bottom, there is a sizable fraction that actually float to the top and stay there. And I think the reason for that is that hop oils are exactly that. But many of them are oils, hydrocarbons that are actually lighter than water. And so there is a fraction of the material, especially the smaller particles, that can tend to float quite stubbornly. And then if that happens, even if you sludge the material at the bottom and you're transferring the beer to your centrifuge, at the very end of the transfer, you'll get slugs of solids that suddenly start coming through at the very end. Many breweries couldn't understand why this was happening. They're thinking these slugs were bridging in the cone or somehow hanging up. But I think we've seen that it actually is material that literally floats at the top of the beer. And obviously, it's not possible to sludge that off because it's at the top of the tank. So if you continue to empty the tank until empty, what some breweries have seen, that's the material starts to come out, and then suddenly you have pure solids going out your outlet, which tend to block heat exchangers. If they get into the centrifuge at all, they tend to carry over because centrifuges are not designed to handle slugs of particles coming in all at once. And if they carry over, then they can go downstream into the filter, into membranes, basically get major plugging of the lines, getting shutdowns, and that's can be quite expensive and a big hassle for breweries.
Before we jump into kind of each stage of the process, why don't you tell us about what's the difference between this new device and the ISOMix rotary jet mixture that we discussed back on episode 22?
Okay, we have been asked quite a bit whether regular ISOMix rotary jet mixer could be used for dry hopping, and actually we've always had to say no because the classic rotary jet mixer is actually the rotation of the mixer is affected by the flow of the fluid through the mixer. It actually comes in the top and goes through a turbine to some gears and actually makes the rotation from the fluid flow. And while that works very well with classic fermentation, where you have very small soft particles like yeast, it won't work with dry hopping because the concentrations of particles are quite high and the particles themselves are quite hard. And they will actually lodge in the gears almost immediately and hinder the mixer rotation. So the mixer simply cannot tolerate these high level of particles and the nature of the particles themselves. So all along, we've been discouraging customers from using the classic rotary jet mixer for dry hopping. Some have actually tried it because they could see that mixing would be a possible solution for the problems. But what they found is that while they can get a decent mixing, it tends to wear on the mixer quite quickly. They get significant wearing of the gears, and the mixer can stop rotation. And if they shut down halfway through and try to restart, they can get a full pluggage of the mixer that simply cannot be unblocked without taking the mixer out of the tank.
Okay.
So process-wise, it's simply not the classic rotary jet mixer is not able to handle the particle load of dry hopping.
How about walking us through each stage of dry hopping and tell us how the ISOMix external drive can improve the process at each stage?
Okay. Typically, dry hopping is, you could say there are 4 stages of the process. The first stage is the introduction of the hops into the tank. So these need to be brought in some way, and preferably not with an excess of air because oxygen is not good for the hop flavors. So the first step is introduction. The next step will be disaggregation. That's basically the swelling and slurrying of the hops. Generally, hop pellets will break up and they will swell. They'll swell to about 6 times the volume that they originally have. And then the third stage is extraction and mass transfer. That's where you're extracting the flavors and aromas from the hop pellets into the beer itself. And the final stage is removal, in which you actually separate the hop particles from the beer. For the introduction stage of the process, the ISOMix external drive can work together with just about any standard method of hop introduction. Typically, hops are introduced to the system either by pre-slurrying, in which the pellets are mixed into a small external tank and added to let's say, deaerated water, and then usually with the help of an agitator are broken up into a slurry, which is then injected into the tank. That's one method. Another method of introducing the hops is a type of pneumatic introduction. For example, Handman has a system called hops to the top, and this is basically conveying the hop particles directly into the tank by means of, for example, carbon dioxide gas. In that case, there's no need to have a slurry tank. You can actually just carry the particles, typically to the top of the tank through the top plate, and which they then enter the tank and fall through the beer. The IMXD can handle either of these types of hops introduction or any other type. It can handle the full hop particles themselves. So in other words, it can circulate the full hop particles if they are introduced directly into the tank. Or if you're going to pre-slurry the circulation system, the circulation of beer through the IMXD gives you a good medium to inject a slurry, even a thick slurry, into the pump suction of the IMXD loop, where it can very quickly be dispersed into the beer and dispersed throughout the tank.
Coming up.
The system is expected to be released at the end of this year, but in the meantime, we are offering the system in prototype form to any customers who are interested to try it for dry hopping.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Here's what's coming up on the Master Brewers calendar. The Fundamentals of Cut and Stack Labeling webinars, February 19th. District Rocky Mountain meets at AB in Fort Collins, February 22nd. District Philly will be at Trogs, February 23rd. District Milwaukee and the Wisconsin Brewers Guild hold a joint technical conference March 1st and 2nd at Badger State Brewing. District Mid-South meets at Mill Creek in Nashville, March 2nd and 3rd. District Northern Rockies meets in Bozeman, March 2nd. The District Midwest Spring Meeting is at Mad Tree Brewing, March 10th. Districts Michigan and St. Louis both meet March 15th. And check out the speaker lineup for the 2018 Eastern Technical Conference, March 23rd and 24th in Atlantic City. View the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show.
Basically, the mixing process run by the IMXD very quickly moves the hop particles, disperses them throughout the beer volume, and actually helps to expedite or accelerate mass transfer. We've made tests on a customer site, basically by taking aroma or flavor aroma analysis of the beer before and during and then after dry hopping. What we found is that using the IMXD, you get higher levels of the aromas after just several hours, 3, 4, 5 hours, than you do after 3 or 4 days of a conventional dry hopping process where there is no mixing. What we find is that you actually make a much faster extraction, so that this customer found that they could reduce their dry hopping residence time from 3 to 7 days down to less than 1 day using the IMXD.
I don't know if you saw the presentation that Sebastian Hintz from the Barth Haas Group gave during the 2016 World Brewing Congress, but they did some lab trials, I believe it was at VLB, which demonstrated a faster and more efficient extraction when dry hopping is a mixed process. They were just using Erlenmeyer flasks and magnetic stir plates, so it's interesting to compare their lab scale results to results you saw in a real brewery and see the charts that you had in your article there too.
Yeah, absolutely. I mean, I've understood now that in some breweries, for example, in the U.S., they are making pump around loops of a sort to affect this kind of mixing process. Mm-hmm. So a number of breweries have been taking it into their own hands. But one of the advantages of IMXD is that it gives you the ability to make efficient mixing in also very large volumes, which is rather difficult with pump arounds. Yeah. Or any other type of mixing system. So this, since it's good to know that on the experimental scale, the efficiency of mixing has been proven, and now we can take that one step further and be able to show the efficiency of mixing on large scale with this IMXD unit.
Okay, well, tell us about removal.
All right. The last step of dry hopping is removal, and as I've mentioned, removal has been quite a headache on large scale for many breweries because of the behavior of the hops in the tank, that not only do many of them drop to the bottom quite quickly, but also a fraction floats to the top. So the object of the removal is to actually try to get the hops out, but not to let it take a lot of beer with them. And on the theoretical side, the best way to do that would be centrifugation, where you can actually spin out the particles and recover all the beer. In order for centrifugation to be effective, though, or to work well, you need to be able to give a homogeneous particle load to the centrifuge. Centrifuges don't work well when they get slugs of particles all at once. They simply can't handle the swings in particle concentration. So that's where the IMXD has its greatest advantage, you might say. The mixer is located quite low in the tanks, usually put at a level about halfway up the conical section. And there it's basically sitting below most of the beer, so it can continue to run during the transfer of the beer out of the tank to the centrifuge. So it runs until the tank is nearly empty, in that way keeping a homogeneous distribution of the hop particles in the beer as it goes to the centrifuge. And our tests have shown that you get perfectly efficient centrifugation since you're sending a very consistent and predictable particle load. The centrifuge, then you can run your centrifuge at a rate to be able to remove these particles completely.
Looking at sensory analysis, have you seen any differences in beer flavor or aroma at breweries that have installed the ISOMix for dry hopping?
So far, the tests that were done, they've been done some blind testing at our first customer to test whether they could taste the difference. And they were not able to taste any significant difference between the beer that was made with the IMXD from the beer that was made with conventional dry hopping techniques. So they were quite satisfied themselves that there was no effect to the flavor that would be noticeable. They were getting the same beer that they had made, but just much faster and with much less loss than before.
Well, listeners can tune into episode 22 to hear more about the other applications of your mixing systems that go beyond this dry hopping application. But how about giving us a quick review of some of the other benefits of mixed fermentations?
Sure. The IMXD can actually perform all of the functions that a standard isomix system can, plus the dry hopping. And the standard isomix system is quite beneficial for the optimization of fermentation, basically both to homogenize the tank, so to reduce any stratification and temperature differences. It keeps the yeast in homogeneous fermentation throughout the primary fermentation, does not allow premature settling, and with that reduces yeast stress and can reduce the concentrations of byproducts or off flavors associated with yeast stress, such as acetaldehyde and SO2. It generally improves the real degree of fermentation, gives a better attenuation, especially in the cases of high gravity brewing, where the yeast has a tendency to drop out early because of the high alcohol concentrations. The isomix system prevents this early dropout and helps the beer to come more to attenuation. So you get a higher RDF, lower degree of off flavors, and simply better tasting beer, and often a much faster fermentation. Especially with high gravity brewing, we can see as much as 20 to 30% reduction in fermentation time compared to non-mixed fermentations.
Great. You mentioned 200 hectoliters as the smallest tank that would make sense for the ISOMix. Obviously, there are a whole lot of dry hopping craft brewers out there with batch sizes smaller than that. Is there any possibility for a comparable solution for those smaller breweries?
Well, the main use for the main criteria to have IMXD installed in the tank is you need at least a meter under the tank in order to be able to get the system in, And it makes most sense if the tank is, let's say, above 100 to 150 hectoliters. Smaller systems, then it's a bit oversized. We are developing a system that will be based on cross-flow filtration that will be beneficial for dry hop, for optimization of dry hopping for smaller breweries. That system is called the ALHOP, ALHOP. It's also in its prototype stage, but it's a different technology. It's for smaller breweries, and in this case, the hops are actually kept outside of the fermentation or maturation tank, and you have a cross-flow type contact to maximize the extraction of the hops into the beer.
For brewers out there listening who might want to give the ISOMix a try for dry hopping, how should they get started?
The system is expected to be released at the end of this year, but in the meantime, we are offering the system in prototype form to any customers who are interested to try it for dry hopping. So we'd be glad to speak to any breweries who would like to test the system, and we would like to work with you to prove the system and also to possibly help develop it even better with the ideas that you might have.
That was Alyce Hartvigsen here on the Master Brewers Podcast. To learn more about the ISOMix for dry hopping, mixed fermentations, or to get in touch with Alyce, check out her articles in the Master Brewers Technical Quarterly. You can get there from the publications menu or by typing mix into the industry's best search bar at mbaa.com. As you all know, Master Brewers is a non-profit organization. You probably also realize that it's expensive to produce shows like the Master Brewers Podcast every week. If you're a vendor, please consider sponsoring the Master Brewers Podcast. It'll cost you less than you probably spent to sponsor that last district meeting, and your message will reach the thousands of brewers who tune in each week. Click contact from masterbrewerspodcast.com to learn more.